Like other three, electromagnetic force is a fundamental force of nature. It's a combination of electric and magnetic force. At the early ages of humanity, electricity was not an understandable phenomenon. In time, we learned how to produce and use it. Today, electricity is an inseparable part of our lives and makes many things easier, like reaching a friend at another continent in a second, giving an order to clear home. To understand all, we need to look at atomic structure. Everything in our universe is made of atoms. The air that we breathe contains 21% of oxygen and 78% of nitrogen atoms. The screen that you are looking and our body made up of atoms. Atom is the smallest particle of matter. Let's have a quick comparison that how small atom is. An average of human height is 170 centimeters. A dog is 50. A rat is 5. An ant 0.2. A bacteria is 1/1 million centimeters. But an average atom's diameter is approximately 0.1 nanometer. It is 10,000 times smaller than a bacteria. Atoms have two main parts, nucleus and orbits around it, and three subatomic particles, neutron, proton, and electron. Neutrons stay in nucleus, symbol of neutrons and 0 or N. Electric charge is 0, in other words, not positively or negatively charged. Mass of the neutron is 1.675 times 10 to the power of minus 27 kilograms. The second subatomic particle is protons. Stay in nucleus with neutrons. Symbol of protons is P positive or P, and they are positively charged. That plus 1.6 times 10 to the power of minus 19 coulomb. Mass of proton is slightly less than neutron. If you have noticed that before, same charge magnets repel each other. Like magnets, protons repel each other too, but a natural phenomena. Binds protons and neutrons in nucleus. Also proton number known as atomic number, written top left to the representation of element. And atomic number is unique for each element. In other words, it determines which element it is, electron number, and chemical behavior. Before electron, we need to understand the second part of atoms, orbits, where electrons keep their movement. Orbits and electrons are directly related to electricity, conductor, semiconductor, and insulator. The main movement field of electrons known as shell or energy level. From inner to outermost shell, they are labeled as K, L, M, N, O, P, and Q, or numbered from 1 to 7. The first shell has lower energy level and it increases towards the outer shell. All shells have subshells, which are labeled with lowercase, from lower to higher energy level S, P, D, and F, but not all shells have all subshells. For example, the first shell only has one subshell, S. The second one has S and P, but not D and F. The reason of that, some subshells energy level higher than shells. That is why all shells have not all subshells. According to this information, the first shell has S, second S and P, third S, P, and D. The fourth one and others have S, P, D, and F subshells. And all subshells have different number of orbitals, that a region of space where electrons present around it. S subshell has one orbital, P3, D5, and F subshell has 7 orbitals. One orbital can hold at max 2 electrons, thus S orbital can hold at max 2 electrons because S subshell has 1 orbital. P can 6, D 10, F can hold at max 14 electrons. While showing electrons on orbitals, a basic line represents 1 orbital, and one arrowhead line represents 1 electrons. With all this knowledge, we can calculate that how many electrons can occupy the shells. The first one can hold 2 electrons, second one 8, third one 18, fourth one 32, fifth one 32, sixth one 18. The seventh shell can hold at max 8 electrons. A quick summary of orbitals to make it clear. Atoms have orbits around nucleus, where electrons keep their movements, labeled K, L, M, N, O, P, and Q, or numbered from 1 to 7. All shells have subshells, labeled with lowercase s, p, d, and f. Subshells have different number of orbitals. S has 1, p 3, d 5, f has 7 orbitals. An orbital can hold at max 2 electrons. The first shell can hold at max 2, second 8, third 18, fourth 32, fifth 32, sixth 18, seventh can 8 electrons. The third atomic particle, our hero, electron. Electrons keep their movement on shells. Symbol is E- or E. Unlike protons, electrons are negatively charged, and it is 1836 times lighter than protons. Like opposite charge magnets, protons and electrons attract each other too. Here's question: why electrons do not crush nucleus? The answer is speed of electrons, that just a percent less than the light, and that brings kinetic energy which keeps electrons on orbits and prevents crushing to nucleus. Number of electron of an atom is equal to proton number. That means atom is not positively or negatively charged, it is neutral. But for some reason atoms may gain or lose electrons. In this inequality, atoms are named as ions. It may positively or negatively charged. Let's have a look for electron configuration, valence shell and valence electron, free electron, and occurring electricity. The first of our example is argon, one of the noble gases. That does not react with anything, and we will see the reason. Depends on Aufbau rule, electrons firstly occupy lower energy level. As we mentioned, the lowest energy level is the first one. Then, 2 electrons occupy S subshell of first energy level. And 2 electrons S, 6 electrons, occupy P subshell of the second energy level. Because P subshell has 3 orbitals and can hold up to 6 electrons. Like second, the third energy level holds 8 electrons. 2 at S, and 6 at P subshell. Like argon, atoms tend to fill last energy level with 8 electrons. In other words, valence shell. It is named as octet rule. Such these atoms have greater stability. That is why they do not react with others and called noble gases. Energy state of some subshells from different shells may be lower than other. For example, S subshell of the fourth shell has lower energy level than the D subshell of the third shell. To not memorize these kind of exceptions, diagonal rule is a logical map that helps us while distributing electrons. Subshells of same shells are written as a row from the lowest to higher energy level, from left to right. In this expression, first number represents the shell, lowercase letter represents subshell, and right top number represents how many electrons occupy the orbital. Then to follow Aufbau rule, first line is drawn from top right to the bottom left. First intersection with subshell is written. If there is no more intersection, next line is drawn, and intersections are written. With diagonal rule, Aufbau rule may properly apply with exceptions. For this video, our last example is a conductor, that widely used material in electricity. Copper has 29 electrons, that is one of the electron configuration exception, that we will see it with reason at outermost shell. Depends on Aufbau and diagonal rule. The first line shows that S subshell of first shell holds 2 electrons. With second line, 2 electrons occupy a subshell of the second shell. The third line firstly intersects with 2p, then the second shell is completed. With second intersection, 2 electrons occupy the s subshell of the third shell. With the fourth line, 6 electrons occupy p subshell of the third shell, and 2 electrons occupy s subshell of the fourth shell. The fifth line firstly intersects with d subshell of the third shell. With this intersection, last 9 electrons are distributed. The electron configuration of copper is found as 2 electrons stay at the first shell, 8 at the second, 17 at the third, 2 electrons stay at the fourth shell. But here is exception that occurs d subshells in general. Hund's rule say, while distributing electrons, fill orbitals firstly with just one single electron, then add second ones. Also for d subshells, atoms tend to fill orbitals, half full or full, to reach greater stability, in other words, lower energy level. Thus, d subshell of the third shell holds 10 electrons instead of 9, and s subshell of the fourth shell holds 1 electron instead of 2. And the final electron configuration of copper: 2 electrons stay at the first shell, 8 at the second, 18 at the third, 1 electron stay at the fourth shell. As we mentioned, valence shell is the outermost shell that contain electrons. In this example, valence shell is the fourth one and has 1 electron. The electrons at valence shell are the valence electrons. In this example, number of valence electron is 1. Valence shell and number of valence electrons is directly related to electricity and chemical reactions by applying energy like voltage, heat, or light. Valence electron leave the atom, at this point the electron named as free electron, and move to another atom. Each free electron has electric charge that minus 1.602 times 10 to power of minus 19 coulomb. With these movement of electrically charged free electrons, or in other words, the carrier charge from one point to another, create electricity. Quantities like amount, difference, limitation will be the subject of our next videos. Thank you for watching.